This video is sponsored by The Great Courses Plus. Get a free trial of their on-demand video learning platform by clicking the link in the description. After a horrible, but in hindsight rather obvious miscalculation, you've just been teleported some million miles away from your intended position, placing you in the middle of interstellar space, right in the vicinity of a black hole. You float helplessly. Because you were just supposed to end up at a particular space hub, and the trip should have otherwise been routine, you mostly lack anything of use for the situation other than your enclosed spacesuit, a substantial amount of oxygen, and a high-capacity computer and contact device. You've been trying to coordinate with your contact source in order to provide them with your position, with the idea that the same miscalculation could be made again, but this time, intentionally and with the rescue module. While you have been doing this, the black hole approaches you at an increasing rate, and you have had no way of sufficiently turning yourself around and moving in any other direction. After some more time passes, a rescue module and crew member have been assembled and are in the process of being sent to your location. You feel a moment of slight relief and hope as you are notified of this, which is quickly brought further and further back down as the black sphere of the outer region of the black hole known as the event horizon grows at a rate of change that you can't barely even comprehend. As you approach, the universe and nearby stars begin to diffract in strange ways, streaking and twisting as the gravity of the black hole bends space-time more and more, causing light to orbit around it and you. Your perception becomes increasingly warped, almost like the universe is a fresh tube of toothpaste, and you are being squeezed out of it. Soon, the entire visible universe around the black hole is pushed further and further out of your field of view, which is by now mostly filled with the deathly black of the indescribable void in front of you. Eventually, the rescue module is sent to your location, but in order to ensure the rescue member's safety and avoid the risk of already being too close to the black hole, it is sent a good distance back away from your initial coordinates. Once it arrives, it approaches you from a distance that now, even from where you were originally sent, is a great length away. The rescue member and contact dispatch members observe you through the module's onboard telescopic visual recording device, which is zoomed in on you at about 100x plus magnification. The module is still much too far away for you to see it. At this point, as the gravitational force of the black hole continues to contort space-time more and more, the functions of space and time are beginning to swap, where now the direction of space becomes singular and time becomes almost multi-directional. Relative to the rescue member and everyone else, time has begun to slow down immensely for you. From their perspective, you are moving incredibly slow, nearly motionless and suspended in space. You, dispatch, and the rescuer frantically contact back and forth, trying to determine the limits of the situation in real time, while real time no longer has much of any meaning. It is by this point that it is basically known by everyone but you that you had mostly already been too close or nearly past the event horizon of the black hole by the time the module arrived, and it is too late for a rescue mission to be safely completed with any real probability. By now, you are mostly aware of this as well. You turn your head away from the growing blackness in front of you and look back towards the direction you came, looking for any sight of the rescue module and an impulse of remaining hope and desire to see anyone before you never see anyone ever again. The observable universe behind you appears to be speeding up in time through that of a fisheye lens as the warping black void begins to overtake it more and more. From your perspective, the space module flashes in and out of existence before it can even be noticed. The universe speeds up and you see the future rapidly unfold. As you watch, the nothingness that has filled in front of you begins to fill more and more behind you, and the black hole becomes less of a hole than that of the rest of the entire visible universe. It looks almost as if you are exiting out of a shrinking rubber dome as the universe drifts into the distance, narrowing tighter and tighter into an increasingly tiny orb-like glowing exit door. You have now completely left the known universe. The physics of space and time, as you understand them, have lost all relevance in operation. From here, there is only one way in all directions, no matter what you do and where you go. Everything around you, approaching you, is the singularity of the black hole, the strange, mysterious center that could be the end or edge or breach of all space-time. The rescue member, who has since been instructed to abandon any further approach, observes you as you appear to become completely frozen in space on the outer edge of the black hole. The gravitational force of the black hole had created a dissonance of time and space so extreme between you and the rest of the universe that you appear to be completely frozen in it from the perspective of the module. To everyone else, you haven't even disappeared yet, even though you are already somewhere inside. The rescue module has no choice but to leave you there in what will sort of remain like an infinitely suspended death sight. From your perspective though, everything has continued and you float inside the black hole for some amount of time. At some point, you begin to spaghettify or stretch as the increasingly extreme difference of gravity's effects on your lower body, nearest the singularity, pull more than it does on your upper body. Eventually, you are disintegrated further and further down, all the way to your most minimal and elementary particles. You are, in this moment, entirely theoretical. Of course, no one has, and perhaps no one ever will be, in such a situation, at least not without it being some sort of science fiction or distant future scenario. Thus, we don't really know what happens on the way in or on the inside of a black hole. One, because we can't physically access them, and two, because based on what we do know, even if we could, nothing could ever enter, survive, and come back out to confirm. Despite this though, we do have potentially fairly accurate mathematic, theoretical, and computer-based models that help us understand that if you were in such a scenario, it would maybe go something like that. Although, at least to some extent, the class and type of the black hole could change many of the related effects and occurrences of the experience. Ultimately, we can model and predict these sorts of things, but at a certain point, we obviously can't know for sure. We can and do, however, have a decent sense of how black holes come to form and work on the surface level, which is perhaps equally strange and mysterious. Basically, black holes form when a disproportionately large amount of matter is concentrated down into a disproportionately small amount of space. Theoretically, anything with mass could be turned into a black hole for at least a brief period of time, so long as the object's mass was proportionally condensed down enough. Which is to say, theoretically, if compressed in such a way, you yourself could be turned into a black hole. However, as far as we understand, the only way black holes can properly form and sustain themselves is when a star of large enough mass, much greater than our own sun, dies and collapses down under the force of its own immense gravity. The result of which yields the most powerful, strange, and mysterious thing in the known universe, a point that is known as the Singularity, which is the point that sits at the center of a black hole and causes all the strange phenomena that occurs around it. This point is infinitely small, infinitely dense, and causes gravity to become infinitely great, which then results in an infinite curvature of space-time. The resulting gravitational force becomes so immense that nothing can escape it after crossing a certain outer threshold layer of the black hole, known as the event horizon. After crossing this point, no object or thing in the entire universe can escape it, not even light. However, this is not necessarily even the most perplexing part about black holes. Rather, perhaps the most mysterious and perplexing part is what happens from here. The question of where you, or what was you, ends up going, and what it might mean for our understanding of physics and the nature of everything. Sometime after you would have passed the event horizon and entered the black hole, not only would you break all the way down to your most fundamental particles, but you and everything unique about you, the particular quantum information you carry, appears to potentially disappear completely. The information being referred to here is not necessarily the sort of information we might typically think of, but rather quantum information that describes the properties of atoms and the path of their various formal arrangements, which theoretically, if you hadn't been sucked into a black hole, would always continue to exist even after you're gone. And even more theoretically, if the information could be collected and measured, it would still, long into the future, house and sustain unique information about your physical state. This would be true for everything across the entire history of the universe. In the case of falling into the black hole though, your information is not only swallowed up, but also potentially erased. We know this to be possible because of a discovery made by Stephen Hawking around 1974, which showed that black holes emit radiation, now known as Hawking radiation, and slowly but surely, over a very, very inconceivably long time, radiate their entire mass away until they eventually, in a remote future, die and dissolve away completely. This would then potentially only leave their evaporated radiation behind. The problem here is that their radiation seems to contain no unique information, but rather appears to be a spewing of informational nothingness, all of it being the same as the rest, indistinguishable and impossible to decipher anything from. This is rather terrifying just at face value, but becomes even more terrifying in terms of what it means for physics and our understanding of the universe. The issue here being, a key principle of physics is that no information in the universe can ever be destroyed, and if it is destroyed, much of what defines physics could be wrong. This issue is known as the black hole information paradox. There are a number of ideas that attempt to resolve this paradox, some of which disregard or refute the premise of Hawking's theory, some of which suggest the information collects somewhere we can't quite find or access, either in or on the surface of the black hole, and it still remains somewhere during and after a black hole's lifetime. Others of which suggest that black holes create wormholes, where information is sent from this universe to another universe or a different position in space-time. All of which, these and others unmentioned, currently remain highly theoretical, unprovable, and unresolvable. Ultimately, the paradox of black holes and the very nature of black holes is one of, if not the primary territories of space that remains not only unknown, but essential to our understanding of basically everything else. Even despite the potential loss of quantum information, the very essence of our current general understanding of black holes defies physics and has serious conflicting implications. Everything we understand about the universe is currently built on two pillars: Albert Einstein's theory of general relativity and quantum mechanics. Einstein's theory of general relativity deals with the large macro level of the universe, and quantum mechanics deals with the micro level. Currently, these two pillars work very well on their own, but don't often work very well together, and their unification is generally accepted as one of science and physics' great contemporary issues, the accomplishment of which in the form of some unifying equation would be deemed potentially the theory of everything. Both of these pillars, however, appear to find themselves in a rather strange situation inside black holes, where neither seem to work. Based on Albert Einstein's theory of general relativity, black holes create a singularity, and that's how we are able to form the conclusion of it being there. However, according to physics, that's impossible. You can't have an infinite density or infinite gravitational force or infinite anything in physics. Infinity, to our knowledge, cannot be real in a physical, measurable sense, and when it appears in equations, it's essentially a sign of an error or impossibility, and thus Einstein's theory breaks down. At the minute scale of the singularity, typically quantum field theory would step in, but quantum field theory can't work here either because it can't yet explain gravity, and the functions of black holes and the singularity are primarily based on gravity. And so, it seems that somewhere between the edge and core of black holes is either the separate collapse of both theories, destroying much of our understanding of everything, or the unification of both theories, creating a supposed ultimate theory of everything. In this sense, the primary answer needed for the complete understanding of the universe happens to potentially be contained and hidden in a place that nothing can seem to ever enter and come out of, a potential final frontier of human knowledge guarded by a mammoth-sized galactic beast. Perhaps this beast is undefeatable, or perhaps we simply lack the mathematic weaponry to properly fight it. In the past, for many of the greatest and most confusing paradoxes in history, even greater minds and greater efforts have come along, confronted, and beat them, dissolving such paradoxes away into the falsitical realm forever. And perhaps here, inside black holes, we will do the same again. Either that, or perhaps we will be dissolved by the paradox first. You are, in this moment, elementary particles, traveling closer and closer to the singularity of the black hole you entered some irrelevant time ago. The quantum informational remnants of you remains as it circulates in a way that could only be described beyond material perception. Eventually, it locates inside, on the outside, or somewhere beyond the black hole. Your material collects together or spews and scatters everywhere. It makes no difference. You exist here, at this particular point, at the answer. Your particles reveal what hundreds of thousands of years of civilization has labored to discover, an embodiment of space, time, matter, energy, and features of reality unknown, an unveiling of the limits of the infinite and the unending, succeeding, conformal boundaries of the finite, an explanation of everything. And you are particles. This video was sponsored by The Great Courses Plus. Sustaining curiosity and lifelong education is not only important in life from a practical perspective, but is perhaps also essential for an interesting and enjoyable life as well. And finding helpful, clever ways of doing this can be of great value. The Great Courses Plus is a subscription on-demand video learning platform that provides over 11,000 lectures in a variety of subjects related to science, philosophy, health, literature, arts, personal development, and much more, making learning on your own terms easy and accessible. With content provided by professors from Ivy Leagues and top universities around the world, as well as experts from places like National Geographic and the Smithsonian, courses are reliable, easy to understand, comprehensive, and at the cutting edge. If you're interested in learning more about theories, principles, and current mysteries in physics, one course worth checking out is entitled The Theory of Everything: The Quest to Explain All Reality. The course is taught by senior scientist and professor Don Lincoln, who provides a comprehensive overview of topics related to gravity, space, time, light, quantum particles, dark energy, and much more, ultimately showcasing what these features implicate in terms of possibilities for how, what, and why reality might be, and the ways we are attempting to resolve their remaining mysteries into one cohesive origin story. You can start your free trial of the Great Courses Plus today by visiting thegreatcoursesplus.com/pursuitofwonder or by clicking the link in the description below. Of course, thanks so much for watching in general, and see you next video.